In this video, we're going to look at a different way of representing chemical equations, and these are called ionic equations. So what is an ionic equation? An ionic equation is a more accurate way of writing a chemical change that occurs in a solution. Take this reaction, for example. You've got calcium carbonate reacting with hydrochloric acid to form calcium chloride ion solution, water and carbon dioxide. What we do now is we look at the species and find out what species are participating in the chemical change and what species are not. So if you look at the calcium here, it's a solid and it's in calcium carbonate. But over on the product side, it's now in solution. So the calcium is a participant because it's changing its form. If you look at the carbonate ions, it actually breaks down. So the carbon and the oxygens in the carbonate are participating because they're breaking down. If you look at the hydrogen ions, the hydrogen goes from hydrogen ions here to water. So it's actually changing its format. So it's a participant. But if you look at the chloride ions, here they're just sitting in solution and here they're just sitting in solution. So they're floating around doing nothing. They are spectators, the same as you're a spectator if you're watching a netball match, but you're a participant if you're on the ground playing the game. So the chloride ions are spectators. So when we write the ionic equation, we write them without the spectator. Calcium carbonate solid plus 2 hydrogen ions gives calcium ions plus water plus carbon dioxide. Okay, there are a number of rules for writing ionic equations. So if you are a strong electrolyte, they're written in ionic form. Now, strong electrolytes are your strong acids. So your hydrochloric acid, for example, is written as hydrogen ions and chloride ions. Your sulfuric acid is written as 2 hydrogen ions plus a sulfate ion. Now, weak electrolytes are written in molecular form. So if you've got something like a weak acid, such as ethanoic acid, it stays as ethanoic acid. Ammonia is a weak electrolyte, so it stays as ammonia. Non-electrolytes are written in molecular form. Water is a non-electrolyte, or a very weak one, and stays as water. So is alcohol, is a non-electrolyte, so it stays as molecular form. So is sugar. It's a non-electrolyte, doesn't conduct electricity, so stays in molecular form. Insoluble substances are written as the formula of the substance. So calcium carbonate is insoluble, so it stays as calcium carbonate. Cobalt phosphate is insoluble, so it stays as cobalt phosphate, written like this. Gases are still written in their molecular form. And ionic equations should not include spectator ions, and the reactions must balance both matter and charge. So what's the key point here? The key point is you can only break up soluble ionic solids, ionic substances, and strong acids. Now let's try some examples. Now let's try an example. Silver nitrate solution is added to a sodium carbonate solution. I'm going to start by writing the molecular equation. So silver nitrate is added to sodium carbonate solution. Now I'm going to use chop kapow. I'm going to get silver carbonate. And using my solubility tables, I find that that is a solid plus sodium nitrate solution. Now, before I do anything, I'm going to balance. So I'm going to balance my molecular equation. Now, state symbols are really important here because that gives us an idea of what we're allowed to break up. As this is a soluble ionic compound, I'm allowed to break this one up. As this one here too is a soluble ionic compound, I can break this one up. This is a solid. I can't break it up. It exists stuck together, so it has to stay stuck together. And this one here is a soluble ionic compound which can be broken up. So let's go through and break them up. So now I've got 2 silver ions in solution plus 2 nitrate ions in solution is added to 2 sodium ions in solution. See how the 2 here went to 2 in front when it was dissolved. Add a carbonate ion in solution. Gives us silver carbonate, which is not allowed to be broken up. Add 2 sodium ions in solution plus 2 nitrate ions in solution. Now, we have to work out what's participating and what is a spectator. If you look at this, the silver ions here go from being in solution to in a solid. So they're doing something. So they're going to stay. The nitrate ions here are in solution, and here they're still in solution. You can tell nitrate ions are aqueous, nitrate ions aqueous. Exactly the same thing. Cross them off. They are a spectator. The 2 sodium ions here in solution are 2 sodium ions here in solution as well. They haven't done anything. They're a spectator. Cross them off. The carbonate ions are in solution, and here they've gone into a solid. So they've done something. They're participating. Now I rewrite 2 silver ions plus carbonate ion gives us silver carbonate. So we've written an ionic equation. Now our last step is we have to check that our matter is balanced. So let's go through and check that. We've got 2 silvers here and 2 silvers here. We've got 1 carbonate here, 1 carbonate here. Our matter is balanced. The next step is check the charge is balanced. So you look at the entire reactants. So if we look at all the reactants here, we've got 2 lots of +1, which is +2. Add 2 negative is 0. So the reactant side adds up to 0. If you look at the product side, it too adds up to 0. So it is balanced. So therefore we have balanced our ionic equation. Now let's try another example. This time we've got sodium carbonate is added to hydrochloric acid. So it's an acid and a carbonate reaction. So sodium carbonate. Now because it's just said sodium carbonate, that must be a solid because ionic compounds are solids at room temperature. It's added to hydrochloric acid, which is a strong acid, so it's a strong electrolyte and it's aqueous. Acid plus carbonate gives salt, which is sodium chloride, which checking our solubility tables is aqueous, plus water, plus CO2. We need to balance, so 2 sodiums, 2 sodiums, 2 chlorines, 2 hydrogens, 2 hydrogens, carbon, yeah, it's balanced. So let's work out what we can break up. Now this here is a solid. Solids are not allowed to be broken up. They stay exactly as it is. This here is a strong acid, which is a strong electrolyte, so that gets broken up. This here is an ionic compound, which is soluble in water, so that is broken up. It's existing as ions in solution. This is a molecule. It does not get to be broken up. Get no choice here. It stays exactly as it is. This here is a gas. Gases too are not allowed to be broken up. So now let's rewrite. So sodium carbonate being a solid stays exactly as it was. Now plus there are 2 hydrochlorics, so 2 hydrogen ions plus 2 chloride ions. The sodium chloride gets broken up. 2 sodium ions plus 2 chloride ions. Not allowed to break up water, and not allowed to break up carbon dioxide gas. Okay, let's go through and find our spectators. The sodium ions here in the solid go into solution. They're doing something, so they're all good. The carbonates get broken down into water and carbon dioxide, so they're doing something. The hydrogen ions end up in water. They're doing some. The chloride ions here are chloride ions here. They're exactly the same. They've done nothing. They are a spectator. Cross them off. Now we rewrite. Okay, last step. We need to check that our matter is balanced. So we've got 2 sodiums here, 2 sodiums here, 1 carbon, 2 hydrogens, 3 oxygens, 1 plus 2 is 3. So our matter is balanced. Now we need to see if the charge is balanced. So we add up the entire reactant side. So this thing is 0 plus 2 lots of plus 1 is plus 2. Let's add up the product sign. This is 2 lots of plus 1 is plus 2, plus 0, so it's plus 2. So our charge is balanced. So we have now balanced our ionic equation. Let's try another example. This time we're adding sodium hydroxide solution is added to ethanoic acid. So this is an acid-base reaction. Start by writing the molecular equation. Sodium hydroxide, aqueous, plus ethanoic acid, aqueous, goes to sodium ethanoate, salt, plus water. Now it's actually already balanced, so we're quite lucky here. So let's see what we can break up. We're allowed to break up an ionic compound that's dissolved in water, so that's going to be broken up. Now ethanoic acid is a weak acid, so it is a weak electrolyte, so it stays stuck together. Sodium ethanoate is an ionic compound dissolved in water, so that can be broken up. And water is just a molecule, so it's not allowed to be broken up. So let's rewrite. Sodium ions plus hydroxide ions plus ethanoic acid goes to sodium ions plus ethanoate ions Okay, so now we need to find our spectators. So if you look at the sodium ion here, it's in solution, and here it's in solution. It's actually done nothing. Cross it off because it's a spectator. The hydroxide ions, there's no hydroxide ions on the other side. It's ended up in water, so that's done something. Then ethanoic acid has ended up in ethanoate ion and hydrogen in the water, so it's done something. So let's rewrite. And what we finish with is hydroxide ions plus ethanoic acid goes to ethanoate ions plus water. Our last step is we need to check that the matter is balanced. So we've got 1 oxygen there, 1 oxygen there. We've got hydrogens, 1, 2 hydrogens, 2 hydrogens. We've got an ethanoate, got an ethanoate. Matter is balanced. Now we need to check if the charge is balanced. So on this side, the reactants add up to -1. -1 plus 0 is -1. And on this side, the products, -1 plus 0 is -1. So our charge is balanced, so the thing is done. Well done. Now I'd like you to try some yourself. Go to the OneNote, Reactions, Precipitate Reactions, and try one. We'll do some more the next lesson.